Have you ever wondered what it would be like to explore the moon's surface? Not with a rover, but with a drone soaring above its craters. But can a drone, like the ones we see on Earth, actually fly on the moon? The answer is more complicated than you might think. Here on Earth, drones fly by pushing against the air with their spinning propellers, creating lift. But the moon has no air, no atmosphere at all. If you tried to fly a regular drone there, its propellers would spin uselessly, unable to generate lift. The drone would just sit on the lunar surface, grounded by the lack of air. This is the core challenge. Flight on Earth depends on air, but the moon is a vacuum. So, if we want to explore the moon from above, we need a completely new approach. We can't just send a regular drone. We need to invent something entirely different. And that's exactly what NASA's engineers have set out to do. Let's see how they tackled this lunar puzzle. The moon's lack of atmosphere isn't just a problem for flight, it's a problem for survival. On Earth, air cools a drone's motors and electronics. On the moon, there's no air to carry heat away, so components could quickly overheat or freeze. Temperatures swing from blistering heat to extreme cold, far beyond what Earth drones can handle. The moon's surface is covered in abrasive dust, and gravity is only 1/6 of Earth's, making movement and stability a challenge. There's no GPS, no magnetic field to help with navigation. Everything must be autonomous. You can't just modify an Earth drone for the moon. The environment demands a total redesign. No air means no lift or cooling. Wild temperatures threaten electronics, and the terrain is unforgiving. But for engineers, these challenges are an invitation to innovate. Instead of giving up, they asked, what if we could move across the moon in a completely new way? That's where the idea of hopping drones was born. The moon's challenges forced us to dream up something entirely new. Let's meet the Moonfall Drones. 13. When flight is impossible, NASA's solution is simple: hop. Enter the Moonfall Drones, miniature rocket-powered explorers designed to leap across the lunar surface. Instead of spinning propellers, these drones ignite a small rocket engine to launch themselves skyward. The moon's weak gravity means a short burst of thrust can send the drone soaring high and far. Each hop lets the drone glide over craters and obstacles, covering ground that would stop a rover. A single jump can reach up to 1 kilometer high and cover significant distance in just a couple of minutes. By stringing together multiple hops, a Moonfall drone can explore up to 50 kilometers, much faster than any rover. Landing is just as precise. Onboard sensors and computers fire the engine again to slow descent, touching down gently on 4 legs. This hop and stop method opens up areas that were once unreachable, revolutionizing lunar exploration. The Moonfall drones are fully autonomous, making real-time decisions millions of miles from Earth. They're not just machines, they're pioneers ready to explore where wheels can't go. The Moonfall drone's main target: the moon's mysterious South Pole. This region is home to towering sunlit peaks and deep shadowed craters, some of the coldest places in the solar system. Scientists believe water ice may be trapped in these permanently shadowed craters, delivered by ancient comets. Finding water would be a game changer. It could support astronauts, provide oxygen, and even fuel rockets for deeper space missions. The South Pole's rugged terrain is nearly impossible for rovers, but perfect for hopping drones. They can leap over craters and onto ridges, scouting for ice and mapping resources in detail. Each drone is packed with high-resolution cameras and ground-penetrating radar to search for water and study the lunar surface. Solar panels and robust batteries keep them powered through the harsh lunar day and night. These drones are our robotic scouts, unlocking secrets hidden in the moon's shadows. The Moonfall drones are key players in NASA's Artemis program. The mission to return humans to the moon, this time to stay. Artemis aims to build a permanent lunar base, and these drones are the advanced scouts. They'll survey landing sites, map hazards, and find the best spots for future astronauts to live and work. By locating water ice and safe terrain, they'll help decide where humanity's first lunar outpost will be built. Instead of risky astronaut treks, fleets of drones will quickly gather vital data, making lunar exploration safer and smarter. Their work lays the foundation for a sustainable human presence on the Moon. The Moonfall drones are more than machines. They're the first leap toward a new era of exploration. By hopping across the lunar surface, they're paving the way for our return to the Moon and our journey to the stars beyond.